What is a sequence? It is a set of numbers which are written in some particular order. For example, take the numbers 1, 3, 5, 7, 9, etc. Here we seem to have a rule. We have a sequence of odd numbers. To put this another way, we start with the number 1, which is an odd number, and then each successive number is obtained by adding 2 to give the next odd numbers: 1, 4, 9, 16, 25, etc. This is the sequence of square numbers. In each case, the dots written at the end indicates that we must consider the sequence as an infinite sequence, so that it goes on forever. On the other hand, we can also have finite sequences. The numbers 1, 3, 5, 9 form a finite sequence containing just 4 numbers. The numbers 1, 4, 9, 16 also form a finite sequence. And the numbers 1, 2, 3, 4, 5, 6 to n are the numbers we use for counting, and we have included n of them. Here the dots indicate that we haven't written all the numbers down explicitly. The n after the dots tells us that this is a finite sequence, and that the last number is n. We often use an algebraic notation for sequences. We might call the first term in a sequence u the first, the second term u the second, and so on. With this same notation, we would write u the nth to represent the nth term in the sequence. So u the first, u the second, u the third, to u-nth would represent a finite sequence containing n terms. We would write sum of un-1 as index and un-2 as index is equal u the nth, to say that each term was the sum of 2 prosodic terms. A series is something we obtain from a sequence by adding all the terms together. For example, suppose we have the sequence u the first, u the second, u the third to u-nth. The series we obtain from this is u the first plus u the second plus u the third 2 plus u-nth, and we write as nth for the sum of these n terms. So although the ideas of a sequence and a series are related, there's an important distinction between them. For example, let us consider the sequence of numbers 1, 2, 3, 4, 5, 6 to n. Then s the first is equal 1, as it is the sum of just the first term of its own. The sum of the first 2 terms is as the second is equal sum of 1 and 2, which is equal 3. Continuing, we get s the third is equal sum of 1 and 2 and 3, which is equal 6. S the fourth is equal sum of 1 and 2 and 3 and 4, which is equal 10, and so on. Consider these 2 common sequences 1, 3, 5, 7, etc. and 0, 10, 20, 30, 40, etc. It is easy to see how these sequences are formed. They each start with a particular first term, and then to get successive terms we just add a fixed value to the previous term. In the first sequence, we add 2 to get the next term, and in the second sequence, we add 10. So the difference between consecutive terms in each sequence is a constant. We could also subtract a constant instead, because that is just the same as adding a negative constant. For example, in the sequence 8, 5, 2, 1 with the minus, 4 with the minus, etc., the difference between the consecutive terms is 3 with the minus. Any sequence with this property is called an arithmetic progression, or AP for short. We can use algebraic notation to represent an arithmetic progression. We shall let A stand for the first term of the sequence and let D stand for the common difference between successive terms. For example, our first sequence could be written as 1, 1 plus 2, 1 plus 2 2 times, 1 plus 3 2 times, 1 plus 4 2 times, etc. And this can be written as A plus D, A plus D 2 times, A plus D 3 times, A plus D 4 times, etc., where A is equal 1 is the first term and D is equal 2 is the common difference. If we wanted to write down the nth term, we would have A plus n minus 1 D times, because if there are n terms in the sequence, there must be n minus 1 common differences between successive terms, so that we must add on n minus 1 D times to the starting value A. We also sometimes write L for the last term of a finite sequence, and so in this case we would have L is equal A plus n minus 1 D times. Sometimes we want to add the terms of a sequence. What would we get if we wanted to add the first 10 terms of an arithmetic progression? We would get S the nth is equal A plus D plus A plus D 2 times, 2 plus L minus D 2 times, plus L minus D plus L. Now this is now a series, as we have added together the n terms of a sequence. This is an arithmetic series, and we can find its sum by using a trick. Let us write the series down again, but this time we shall write it down with the terms in reverse order. We get S the nth is equal L plus L minus D plus L minus D 2 times, 2 plus A plus D 2 times, plus A plus D plus A. We are now going to add these two series together. On the left hand side, we just get S the nth 2 times. But on the right hand side, we are going to add the terms in the two series so that each term in the first series will be added to the term vertically below it in the second series. We get S the nth 2 times is equal A plus L plus A plus L plus A plus L 2 plus A plus L plus A plus L plus A plus L. And on the right hand side there are n copies of A plus L, so we get S the nth 2 times is equal n times A plus L. But of course, we want S the nth rather than S the nth 2 times, and so we divide by 2 to get S the nth is equal A plus L half of n times. We can also find an expression for the sum in terms of the A, n, and the common difference D. To do this, we just substitute our formula for L into our formula for S the nth. From L is equal A plus n minus 1 D times and S the nth is equal A plus L half n times, we obtain S the nth is equal A plus n minus 1 D times multiplied on half of n, which is equal A 2 times plus D times n minus 1 multiplied on half of n.